let's take a look at some limits and think about continuity and see if these functions are going to be continuous as our x values approach these specific values. So rapid fire here. The first one, we have a trinomial, a third degree polynomial, x cubed minus 4x. So this is a polynomial. Polynomials tend to be continuous everywhere. We don't have any problems as far as we are not allowed to plug in specific values of x, that sort of thing. So they're said to be smooth and continuous. So to evaluate this, and a lot of these are going to be this way, what you can do is you can simply plug that x value in for each one of the x's. So in this case, we get 8 minus 8 works out to be 0, but that's okay. That limit is going to equal 0. Similarly, on the next one, even though it's a rational function, it's okay to first start out with each one of these and simply try to evaluate when we plug in that value where our x values are approaching. So in this case, we'd get 2 replacing each one of the x's, and this works out to be negative 2 over 5. All right, so that limit does exist, and it's going to be at negative 2/5. Now, thinking about rational functions, we would run into a problem looking at this x in the denominator. If we try to replace x with negative 3, if x equals negative 3, we would run into a problem on this one because we would be dividing by zeros, and with rational functions, we know we're not allowed to divide by 0. That may come up on this next one. So taking a look at this, if we first try to evaluate it at x equals 2, that would mean replacing each one of our x's with 2's. We're going to end up with negative 2 divided by 0. And that comes out to be a problem, right? We can't divide by 0. We'd say this limit does not exist. However, there are some other cases here where we're going to be able to actually try to evaluate first by plugging in that value of x that we're getting close to, but sometimes we can deal with it in different ways. Let's take a look at this one. The limit as x approaches 8 of x minus 8 over the factored form here, quantity x minus 8 times x plus 1. Let's first start by trying to evaluate it by simply plugging in 8. So for each one of the x's, let's evaluate this by plugging in 8, replacing each of the x's with 8. This will work out to be 0 over 0 times 9. Well, 0 over 0, we can't really say whether we have a limit or not in this case. However, we could put this in what we sometimes refer to as lowest terms. If we reduce our fraction to lowest terms, that means that we're going to take the common factor between numerator and denominator, the x minus 8's, simplify down there, and the limit is going to be equivalent to lowest terms 1 over x plus 1. At this point, we can actually go back and reevaluate this by replacing the x that remains with the 8. We can get 1 over 8 plus 1 makes 1/9, and that is going to be this limit, is going to equal 1/9. So what you want to look for are do any factoring if necessary, reduce it to lowest terms, and then evaluate by replacing each of the x's that remain with the x value you're replacing. So as you can see on this next one, we have the limit as x approaches 5. It's already in factored form. Now if I replaced each of the x's with 5's, we're going to get a 0 for this factor and a 0 for this factor. Although that's a good place to start, I'm going to go ahead and begin by getting this to lowest terms, especially because it already comes factored. We can cancel out one of the x minus 5's with another one, leaving us with the limit as x approaches 5 of x plus 2 over x minus 5. All right, so it's in lowest terms. We've reduced down as much as possible by eliminating common factors between numerator and denominator. Now if we try to evaluate it by plugging a 5 in, we'll do 5 plus 2 over 5 minus 5. You'll notice that we still end up with a 0 in the denominator. Therefore, we can't reduce any further. We're going to have to stop and say this limit does not exist. All right, so in general, what you want to do is start out and think, all right, if I simply replace in with a negative 7, in this next case, we are going to get a 0 in the denominator. So maybe we just jump right into thinking, can I factor the numerator? So in this case, let's look at the limit as x approaches negative 7. The numerator, I believe, will factor as x plus 7 times, let's think, x minus 9. From here, we can eliminate this common factor, put it in lowest terms. So this will be the same thing as the limit as x approaches negative 7 of x minus 9. From there, we can replace our x with negative 7. Minus 9 is going to be negative 16. So that limit of the big rational function is the same thing as negative 16. All right, hope this helps out. Good luck.